There's multiple types of aerospace engineers. There's aeronautical engineers, which are the engineers that focus on designing aircraft, things that fly in this atmosphere. And then there's aerospace or astronautical engineers that focus on spacecraft.
Well, aerospace engineering is almost a very specialized form of mechanical engineering, where you're looking at the structures of a system, the electronics of a system, the controls of a system. It's a whole system range of different things.
There are aerospace engineers that focus solely on aerodynamics, how air flows over a surface. There's structural engineers that select what materials you're using. They determine what the inside of the aircraft looks like. There's also aerospace engineers that specifically focus on propulsion systems. They design the jet engines, they design rockets, they figure out how you get the aircraft from point A to point B.
You really need somebody who maybe has a specialization in controls working on a team, as well as somebody who is working in structures or somebody who's working in aerodynamics. They're all working together with their specialties, but they need to make sure that they're keeping in mind the other specialties. When I was 6 years old, my parents took me to Space Center Houston, which was right near where I grew up in Texas. And when I saw all of the work that they had done there, I was very inspired. And I decided, okay, this is what I'm going to do. I'm going to be an aerospace engineer one day.
The thing I like most about my job is that every day I can work on something different. And my degrees and my background allow me to create my own career and to work on things I really am interested in.
It's the next step of mankind. You're kind of on the edge of the envelope and improving people's lives and improving the way that we can do things and taking technology that next step further.
A lot of aerospace engineers work in the automotive industry. Aerospace engineers would design the shape of the car to allow for the airflow over the car to get you good efficiency.
So here in our lab we're working on conceptual simulators, so we're looking at aircraft that don't necessarily exist yet and may not exist for another 20 to 30 years. We transfer all of the control laws and how it works, all of the aerodynamics into a model on a computer that we then use to drive the Lamars. So a pilot can sit in there and he can move the stick, and those reactions are then recorded and used to control the simulator or the aircraft in the real world. I'm also working on the Automatic Collision Avoidance Technologies program, which incorporates the automatic ground collision avoidance system.
In my career, I've done everything from designing parts on cars, to designing aircraft engines, to designing morphing aircraft. Morphing aircraft design is aircraft that can change shape during flight, which is the tricky part, to get an additional performance benefit. I guess I would be considered a rocket scientist, but I really don't like that terminology for myself. You do have to have a foundation in math and science to be an engineer, but I think that it's a mistake to think that you have to be a genius.
Aerospace engineering definitely fits within the science, technology, engineering, and math fields. It is very heavy in the math. I'm using math and science concepts, physics concepts, potentially every day.
Because engineering is so based in a strong foundation of math and science courses, it's really important in high school that you start that foundation early.
If you have the opportunity to take AP classes, be sure you're taking them. Even if you're maybe challenging yourself and you're not making that A in that class that you could make in a lower level class, take it because it'll give you that really good baseline experience.
I actually had people tell me, oh, you'll never use calculus, you'll never use physics in your career. But honestly, all of my physics, calculus, chemistry books are on my bookshelf in my office. Geometry is a really good example when you're trying to size a structure, you're trying to determine how big it should be, and you need to know the area of a trapezoid.
Really, what's almost more important that you learn in an engineering degree is how to solve problems.
So I had that strong foundation, and then when I went to college, I started in mechanical engineering and then decided to go to grad school for aerospace engineering, and here I am.
Finding what interests you the most and that you feel passionate about, because that's a very important aspect of what you're going to be doing for the rest of your life. Kind of three different tracks you can take as an aerospace engineer. You could go a government track where you're working on things to help your country and help technology in general. Or you could go on an academic track where you pretty much stay in the university world and you work within a research lab. You're providing research that different organizations can take to help increase their technology. The third track is a commercial degree, where you're working in the commercial sector. You're producing aircraft in large capacity, selling them to different organizations, airlines, the military, that type of thing.
But depending upon where you work will really decide what your actual career is. You can do everything from management to structural design to propulsion system design to aeronautical aerospace design.
Depending on what track you go into will really determine what higher level graduate degrees you will pursue.
The best part of engineering in general is that it is a very versatile career. There's a lot of things that you can do with an engineering degree.
Usually a person will be working on multiple projects throughout their life. And it's becoming more and more common for the younger generations to move to multiple jobs within their career. Next step for me will be my master's degree.
Somebody has to do the aerodynamics, somebody has to do the structures, somebody has to design the propulsion system. Aerospace engineers are involved in all of that.